chemical reactions of amines. So let us see the basic character in amine. We know amines are derivative of ammonia, so they will be basic. Also, how the basicity changes according to the groups attached to each amine. Due to the inductive effect, what happens means the electron density of the nitrogen atom will be greater compared to ammonia. So the nitrogen atom makes the lone pair are more attractive towards the hydrogen ions, or it can easily attract the H plus or any positive ions, since the electron density in the nitrogen atom will be increased due to the inductive effect of the groups attached to the nitrogen atom. So all the amines are greater basic than the ammonia. It is clear that CH3 groups attached to nitrogen atom, due to the inductive effect, electron density of nitrogen will be increased. So it can be represented by delta minus, and which will be having more basicity. Also, according to the pKa value, ammonia has 9.3 and primary amine is 10.66, secondary amine 10.74 and tertiary amine 9.81. And the basis pKa value is directly related to the basicity. So therefore, the order of basicity is secondary amine is highest basic, and next comes the primary amine, and next comes the tertiary amine. The reason is inductive effect. In the case of aniline is less basic than ammonia, since the phenyl group exerts an inductive effect which withdraws the electron. Phenyl groups withdraws the electron present in the nitrogen atom, and thus leads to less basicity of aniline. Thus the nitrogen will be less available for the protonation. Since the amines are basic, they can be reacting with acid and forms the corresponding salts. Let us see the reactions of amines one by one. First one is the acylation. Acylation is the addition of RCO group to the amine. So here ethanamine, when reacted with acid chloride or anhydride or ester, these type of products will be formed, that is N-ethyl ethanamide. So here the lone pairs present in nitrogen will be shifted to carbon atom, and the double bond will be shifted to oxygen atom, and in the next step HCl will be eliminated and the corresponding product is formed. The reaction takes place in the presence of a base. For the secondary amine also the same reaction is possible, and the product is NN-dimethyl ethanamide. So if the reaction takes place by using benzyl chloride, then the reaction is known as benzoylation. Primary amine, when reacts with benzyl chloride in presence of base, that's pyridine, N-methyl benzamide will be the product. Next one is the diacetyl reaction, or the reaction with the nitrous acid HNO2. Primary amine reacts with HNO2 in presence of NaNO2 and HCl and gives the diazonium chloride, which on hydrolysis gives corresponding alcohol. Similarly, aromatic amine compounds such as aniline reacts with the NaNO2 and HCl in presence at temperature 0 to 4 degrees Celsius and forms benzene diazonium chloride. The process is actually known as the diacetization reaction. The importance is the reaction takes place at very lower temperature. The reaction with nitrous acid for primary, secondary and tertiary amines are different. Primary amines will give corresponding alcohol, while secondary amine gives the corresponding nitroso compounds. Similarly, tertiary amine when reacts with HNO2 gives R3NH plus ONO minus compounds. The aromatic compound, NO substitution will be takes place at the para position. Next, reactions of diazonium salt. The last step we saw the preparation of diazonium chloride by using the amine with the HNO2 or NaNO2 and at a very lower temperature. The diazonium chloride salt will be like this: C6H5 and 2 plus and Cl minus. The importance is these are very unstable and stable at very lower temperature, so that can be converted into different products, or different classes of products can be obtained by using the diazonium chloride. So by using this diazonium chloride, we can prepare alcohol, chlorobenzene, bromobenzene, cyanobenzene, iodobenzene, fluorobenzene, or benzene by using different reagents. For example, reacting with H2O and C2O gives the corresponding alcohol, CuCl gives corresponding chlorobenzene, etc. Next one is the carbylamine reaction. When when an amine reacts with chloroform in presence of KOH, and while heating, it will be converted into isocyanide or carbylamine, and which is having a very foul smell. The reaction is known as the carbylamine reaction. This is the important reaction used in the qualitative analysis of aniline or amines. For aniline also, the same reaction is possible in presence of chloroform and KOH, while heating were converted into isocyanide. Next reaction is the Hofmann's exhaustive methylation. Here, nitrogen atom present in the heterocyclic ring usually methylated by using CH3I, and the reaction is known as Hofmann exhaustive methylation. So further methylation and reacting with the silver oxide, we can remove the nitrogen from the heterocyclic ring, and the reaction is very important in the case of natural products. So here, the compound, heterocyclic compound, when treated with CH3I, presence of potassium carbonate, nitrogen will be methylated and a quaternary salt will be formed. Like here it is primary, and two CH3 groups can be attached to this one, and corresponding salt will be formed. This step is actually known as the Hofmann's exhaustive methylation, which on further treating with silver oxide, the bond will be breaking and corresponding alkynes will be formed. So this is another example in which the two nitrogen atoms are present and which can be methylated. First, here for benzene ring, one methyl group is attached, and for the 5-membered ring, there can be attachment of 2 CH3s possible, and the step is known as the Hofmann's exhaustive methylation. Next reaction is Hofmann's elimination. Here, the tertiary amines and alkenes from quaternary ammonium chloride can be produced. The process is known as Hofmann's elimination. First step is a Hofmann's exhaustive methylation. That is, an amine group will be methylated till the quaternary ammonium salt will be formed. Like here, NRR will be methylated and forms NRRCH3 plus and I minus, and which on treating with silver oxide, I minus will be converted into OH substituted by OH minus, and in the next step, removal of water molecule takes place, and similarly the bond breaking between carbon and nitrogen produces an tertiary amine, and remaining one will be the alkene. So this method is known as the Hofmann's elimination. The process can be applied for cyclic compounds also, and the condition is the compound should contain an beta hydrogen atom. If 2 or more beta hydrogen atoms are present, means which is available for the elimination process, alkene will be having the less substituted double bond will be formed. Less substituted beta hydrogen will be forming the corresponding double bond. And for the mechanism here, first the amine, nitrogen atom containing lone pair of electrons, which will be shifted to carbon atom, and the bond between carbon and iodide will be shifted to iodine, and iodine will be liberated as I minus, and which will be attached to like this. A salt will be formed, amine and salt will be formed. The next step, silver oxide Ag2O, the electrons from I minus will be abstracted by the silver, and bond breaking takes place between silver and oxygen, and silver iodide will be precipitated. Remaining silver oxide abstracts one proton from water and forms silver hydroxide, and from that OH minus will be formed. The next step, this OH minus abstracts a proton and the bond will be shifted like this. Finally N, R3, R2 and CH3 will be eliminated, and also what molecule is eliminated? The remaining will be an alkene. Next one is Mannich reaction. Here amines reacting with carbonyl compounds such as formaldehyde or any other carbonyl compounds and forms beta amino carbonyl compound, and it is a base known as Mannich base, beta amino carbonyl compound. Coming to the mechanism of this reaction, first the carbonyl compounds abstracts a proton and corresponding OH plus will be formed, which will be added to the amine, from which the electrons from the nitrogen atom will be shifted to carbon atom. Again double bond will be shifted to OH and a bond formation between amine and the compound takes place. The next step, an H plus will be eliminated from this one and corresponding product will be formed. Then again an abstraction of H plus by oxygen or OH takes place and H2O plus will be formed. It will be eliminated as water and this product will be formed, N plus R2 R1 and plus double bond CHH. The next step, again one more carbonyl compound is there which will abstract a proton and forms OH plus. In the next step, abstract a proton from hydrogen from the adjacent carbon atom and forms the removal of H from the adjacent carbon atom and forms corresponding product like this, which again reacts with the compound of first step. Here the electrons present in oxygen atom will be shifted to this bond, the double bond will be shifted to carbon atom, and again double bond will be shifted to nitrogen atom and corresponding product will be formed, OH plus and R3, N, R1, R2, etc. The last step, one more proton will be eliminated from OH plus and the corresponding product will be formed, that is beta amino carbonyl compound. It is the beta amino carbonyl compound. This amino group is present in the beta carbon atom to this carbonyl group.